want to talk about chemical reactions and chemical equilibrium. Now, we've been talking about chemical reactions, we're talking about energy changes, we're talking about reactions, but then we want to talk about the types of these reactions. Now, the first basic type of reactions we're talking about is combination reactions. And these combination reactions involve whenever you have a compound or an element combining with another compound or element. So, and then, for example, this example of combination is combination. When you have iron reacting with sulfur to form iron sulfide. So this is a good example of combination reaction. And then note that all of the elements are in solid phase. S, solid, and solid. Another type of reaction you could encounter is dissociation. And then this dissociation is basically whenever you have a compound dissociating into two or more elements. So and then, for example, when you have dissociation. So in this dissociation, we could have something like this dissociation it could be known as thermal dissociation. So it's also known as thermal dissociation. For example, when we have dinitrogen tetroxide N2O4, when it is dissociating into the brown nitrogen oxide NO2. So this is an example of thermal dissociation, and thermal dissociations, they are always reversible. So it's a reversible reaction. So whenever you increase the temperature, you can have this one N2O4 at a particular temperature. You have the nitrogen tetroxide. Then whenever you increase the temperature or decrease the temperature, you can have NO2. That's nitrogen dioxide. So and then this is a reversible reaction. So it goes in the first and goes in the second. So and then there are often stages of equilibrium, which we'll be talking about later. Then we also have decomposition. So in decomposition reaction, you have a compound breaking down into two or more elements. So whenever you have calcium tetracarbonate 4 and CaCO3, calcium tetracarbonate 4 decomposing into calcium oxide and CO2. So this is an example of a decomposition reaction. So and then we also have displacement reaction. So in this kind of reaction, you can see that one of the elements is displacing another in a compound. So whenever you have zinc element reacting with tetrasulfate 6 H2SO4, so this zinc element will replace the hydrogen. That will be ZnSO4. So the hydrogen will become what? Displaced. So that's H2. It's just like whenever you have the change of government from one president to another president. So in this case in chemistry, one element is taking the place of another, and the other elements, they are changing, just like they are swapping places. So and then we have double decomposition. So in basically double decomposition, whenever you have two compounds, so those two compounds, they exchange ions. If you have compound AB and a compound CD reacting together, so whenever they encounter double decomposition, you have your product A, your product AC, and your product BD. So your AB has swapped with your CD and it has turned to AC. Your CD has swapped with AB and it has turned to BD. So that's an example. An example of this is that whenever you have your copper tetrasulfate 6 reacting with hydrogen sulfide to give you copper sulfide and hydrogen tetrasulfate 6. So that is a change. And even in the WAEC examination, the WAEC chemistry practical of 2021, it involved a double decomposition where you had two compounds, a copper compound and an ammonium compound reacting together to exchange radicals. So and then those were, I guess they were copper tetrasulfate 6 and ammonium tetracarbonate. So they reacted together, they formed double decomposition to give you copper tetracarbonate 4 and ammonium tetracarbonate 6. So that's an example of double decomposition. Then we also have lastly, and the most important part of this reaction, is the reversible reaction. So that will be number 5, reversible reaction. So in reversible reaction, you basically have your products will be reacting to form your product is reacting to form your reactant, then your reactant is also reacting again to form your product. So it's a reaction that goes in two ways. So and then this reversible reaction, example of this is when you have your copper tetrasulfate 6 pentahydrate, and whenever you heat it up, it will give off its water of crystallization. So CuSO4 plus 5H2O. When it is heated, it gives off its water of crystallization. It will form CuSO4 plus 5H2O. And at the same time, whenever it's cooled again, it will give back its hydrated form. So that is the reaction proceeds in two directions. So and this is called a reversible reaction. Now in reversible reactions, there's what is known as chemical equilibrium. Now chemical equilibrium involves the forward and the backward reactions. Now in this chemical equilibrium, it involves the fact that whenever the forward reactions and the backward reactions, they are occurring at the same rate, and at the end of the day there's no net reaction. So in this case, the forward reaction and the backward reaction have equal rates, and the result of this is that there's what is known as dynamic equilibrium. Now this equilibrium can be affected by different factors, and these factors, whenever they affect the system, the chemical system under equilibrium, there's what is known as the Le Chatelier's principles, which takes place. And that says that whenever a chemical equilibrium is under any factor or constraint, that the equilibrium will have to shift to annul or cancel out the effects of that equilibrium. So what that means is that, talking about that, we have three different constraints. Popular constraints are changes in temperature, changes in pressure, and changes in concentration. Whenever we have constraints involving changes in temperature, in an endothermic reactions, the forward reaction is favored by increase in temperature, and the backward reaction is disfavored by increase in temperature. So, or rather, you can see the forward reaction is favored by increase in temperature, and the backward reaction is favored by decrease in temperature. When we talk about concentration, in concentration, the forward reaction is favored by increase in concentration, and the backward reaction is favored by decrease in concentration. For in pressure occurs only in gases, and then in those gases, you must have gases at the left and right side of the equation. So, for example, whenever you have a reaction between ammonia, when you have ammonia is formed by nitrogen and hydrogen. So balancing the reaction, this will be 2 and 2 here, and 3. Now you have 2 moles of ammonia is formed. 2 moles of ammonia decomposes to form 1 mole of nitrogen gas and 3 moles of hydrogen gas. So you can notice that they are all gaseous now. G, G, G. So the effect of pressure is that whenever you have an increase in pressure, it favors the forward reaction. It favors the side with lower moles of gases. So what that means is that whenever you have 2 moles of gases on the left hand side, and you have we have 4 moles, so we have 2 moles on the left hand side and 4 moles on the left hand side. So whenever we increase the pressure of the the forward reaction, whenever they increase the pressure, the side with the lower moles of gases is going to be favored. For example, if we increase the pressure here, that means this left side of the equation will be favored. Why? Because this left side has only 2 moles of gases, while the right side has 4 moles of gases. But in the reactions which involve equal moles of gases, for example, the reaction between hydrogen gas and chlorine gas in the presence of sunlight to form hydrogen chloride. So H2, 1 mole of hydrogen and chlorine gas will form 2 moles of hydrogen chloride gas. Now in this reaction, the net number of gases in the left hand side is 2, and the net number of gases in the right hand side is 2. So in this kind of reaction, there is no effect of change in pressure. So if it ever comes to your exam, just know that there is no effect, because there is no change in the number of moles on each side of the pressure. So in sum, we'll talk about different types of reaction: combination, dissociation, double decomposition, and reversible reactions. And then we've talked about the effect of temperature, pressure, and concentration on the reactions. So thank you for watching.